Hey, welcome to the Workflows4s DevLog. It's been a while since we had the last episode, but today we have not one topic, but two. Today we're gonna talk about retries and about a newly added SQL runtime. So let's dive into retries. So what are we trying to achieve and why? As you know, Workflows4s allows you to run arbitrary side effecting or operations, basically I/O of some sort. And obviously this I/O can fail. You can have a timeout, network issue, some database problem, whatever. For various reasons, the I/O can fail, and then you want to retry that. And what is the normal way to do that? Or like a simple way is you use a library like cats retry that allows you to specify a retry strategy and let's say repeat the operations 3 times or do some sort of exponential backoff, whatever you want. And that's great. The problem is that the Workflows4s targets long-running workflows where the whole operation can take days, weeks, months, and the same applies to the error we can see. So if something is not working correctly, there is a chance we need something more than an in-memory retry of, let's say, 10 seconds, 1 minute, whatever. And that's why Workflows4s comes with a dedicated support for long-running, like scheduled retries. So the retries that will happen at arbitrary point in time in the future, and such retries will also survive system restart. So the state is persisted. Okay, so let's look how this works. And today we can change the order a little bit, and we can start with an example. How do we construct the retry? And this is simple. There are two ways to do that. Like we define a wheel of some sort, and then we call retry in 2 minutes or 15 minutes. Like we basically specify a function from the throwable to duration. So this is a simple variant. Then there is a more powerful, more complicated one that takes a function from throwable, the current state, and the time at which this is executed, it returns the I/O of option of instant. In such case, you can do arbitrary side effects also in the retrying logic. At the end of the day, you just have to tell Workflows4s when you want the process to be rescheduled. As simple as that. So how does it work? If we look at the implementation of this, we will see that both those methods in the end construct WIO retry. What is WIO retry? It follows the usual pattern of Workflows4s. When we wrap, we compose stuff by wrapping it. And in that case, we have the base, so the thing that can fail, and we have the handler. Now, let's see where the handler is used. We are now in run IO evaluator. This means that the handler is used only when we evaluate an IO step. This can be a run IO, but it can also be a signal. Basically, whenever we have a side effectful operation. And what happens here? We process the base, and when we look at it, the result type is option of IO of either instant or the event. What does it mean? The option is because there might or might not be anything to execute. Then we have an IO, so the operation that will be that is supposed to be executed, and it returns either an instant or an event. An event in case something was executed and we are supposed to persist the new event, so change the workflow state. Or on the left, we have an instant, which is the retry time. So now what we do is we execute that, map over the option, and handle errors on the I/O. We pass our handler, and we check what happened. As you may have noticed, the handler returns option of instant, so you can decide if you want to handle the error or not. If you did handle, you have to return the retry time, and we just return it. So now we have to look into what happens when we return the instant. So, sorry. Okay. So to do that, we have to check where the proceed evaluator is used. So we are now in active workflow. This is just a utility to wrap the state to interact with a workflow. And we see that there is a wake up call. Now we are in the workflow instance base, but basically this is the implementation of workflow instance. Every workflow instance will probably follow this implementation. And what we have here, we have the proceed being called on the state. And we get our result of I/O. So we execute the I/O. This is actually a little bit wrong. It should be retry or event. And that is produced by I/O. And if it's retry, this is a little bit more complicated than it should be. What is important is that this log outcome will get propagated here. So post event actions. And now if we have, we can have a no operation, no state was updated, but we have some retry time. If the new retry time is before the old retry time, then we update the wake up. What does update wake up do? It just calls knock wrapper. Knock wrapper is a component that you should already know. It's basically a component within a Workflows4s architecture that is responsible for waking up workflows. So there is really no magic here. Like, we have a handler of exception that gives us retry time, and we have a little bit of code that propagates that retry time into the knock wrapper. And that's actually why I decided to implement that, because it was super simple. Now it comes with at least one or two caveats. The first one is that retries are stateless. So if we look again at the retry, you see that this is a function, but there's nothing here that would allow us to persist any kind of state between the retries, almost. So what does it mean? It means that we, for example, cannot do exponential backoff, or we cannot actually terminate the retries. But that's not entirely true. We cannot do this natively. We cannot do this with what Workflows4s offers, but you can easily do that if you really have to on your own end, because you return an I/O here. You can do any kind of state lookup and decide if you want to keep retrying or not. So yes, this is the one caveat. There is also a little bit of space for improvement, because I can imagine a case where you retry and then want to raise a business error. Well, what I mean by that is you want to go a different path, like stop raising errors, like recover, but with a business error. And you cannot do this right now directly from the handler. You have to do this from the wrapped element. But that's probably fine. You can still use the standard timeouts to do that. So hopefully all the most common use cases are addressed. And what I also would like to mention is the difference between technical and business errors. So if we go back to where we started, to the retry example, you see that on the error channel, the second type parameter here is error. And on the error channel in Wio, we have nothing. Why? Because this channel is meant for business errors, meaning errors that modify the path that the workflow takes. If we look at any of the visualizations, this doesn't work. Okay, let's VG maybe. Let's see if I have. Yeah, I have something. So this is a BPMN for some of the processes, but a quick reminder: business errors are those that are visible here and make sense from the business perspective, from the perspective of the workflow shape. So when it's raised, we go different path and do something else. Those two, business and technical errors, are two completely separate things. That being said, all of that is explained in the documentation, so it should be fine. Cool. I think this is all when it comes to retries. So now let's switch to something else. Let's talk about SQL runtime. This is a very new thing contributed by Roman Greshny, who started working with me on Workflows4s a long time ago, when the project was starting. And he implemented that with a little bit of my help. And you may wonder why we need that. Why would we support runtime based on one particular database like SQLite? Does it mean that we're going to support all and every single database? Not really. Because for general use case of persisting workflow state into the database, we have a quite generic database runtime that is based on Duby, and it takes workflow storage that is meant to have the queries for a particular database. So if you need anything, you can configure, like, implement your own workflow storage, which is like 3 methods, and that's it. So in general, you're free to use whatever runtime you want, whatever database you want with database runtime. So why do we have SQL runtime on its own? Because it's a little bit more than what we do with standard databases. With standard databases, you have just an instance running somewhere and you persist state there. Very simple, very boring, very predictable. With SQL runtime, we wanted to do something more adventurous. We wanted to follow the extreme sharding pattern. And you probably haven't heard of that, but extreme sharding is when you create a database per entity. It can be per user, and in our case, it is per workflow. So what does it mean? It means that when you create a workflow with SQL runtime, you specify a workdir, and then the runtime will create a new SQLite file, like new SQLite database, but basically a file in that workdir for each workflow instance. And that's it. Like, then everything works as usual, but the question persists, why do we do that? The first reason is that sometimes you may not want to deal with database maintenance. Let's say you're doing a quick proof of concept, a prototype, or something like that. Or you simply don't care about long-term maintainability and ability to introspect and, like, tune your database. You just want a simple persistent storage. And here we go. You just need a file system. Wherever you deploy, you probably have file system. So this setup is extremely simple. It has very little external dependencies. But what to do in a cluster environment? What if you have more than one instance of your service? Then you can simply mount a volume from your cloud, let's say from Kubernetes. You just have a shared volume and you can write there. There are certain performance implications for that. And theoretically, this approach could scale quite well, but it would require further improvements. Like we would need to archive the finished workflows. We would need to layer them, because there is a limit of how many files you can effectively store in one directory. And that's not a big issue. We just create a tree of directories based on the workflow ID, and that's totally fine. So yeah, this runtime exists because it's interesting, because it's adventurous, not exactly because it's extremely useful. Most of the environments will have a proper database right now, but we're here to both solve problems, but also to have a little bit of fun. And I think this runtime is pretty fun. By the way, the implementation is trivial. Like the whole implementation of the runtime is like 100 lines long. So it's not like this is a huge thing. We just have a work there. We have the storage that just makes sure that we run the right queries. And we have we create a path for a given workflow. We create a transactor for it. And that's it. Then we reuse the things that were already present. So the implementation of workflow instance is the same between this and database runtime. Great. I think that's all I had for you today. Thanks a lot for watching. I have to admit, I'm running a little bit out of stamina for those videos, so if you find them helpful or interesting, please comment, like, whatever, just to give me a little bit of feedback that what I'm doing makes sense. And see you at the next episode.